it will rotate accordingly like this. So from the MSB must go to the X first. Must go. So you need to know the contents of the X by default, whether it's 1 or whether it's 0. So from this value, then will be going to the register, and then it will shift. Same goes to this one. The MSB is going to be rotated here through X. The value of X must be given whether it's 0 or 1 by default. So this value will be going inside here, and the final over here, the one that we are going to copy over here. The first value will copy over here and over here. So that's why they call it through X, melalui X. Okay, let's look at the question. The question is given like this normally, right? So you can see that example of so you can do this one, and you can see that from the question, X is given. X is given as 0 as initial value. So it means that try to use this command in your PC and try to lock down. Now very simple, I don't put that X is equivalent to 1. X is equivalent to 0. By right, your PC flag is all 0. Remember that? By right, by default, your X flag is all 0 at the beginning. The beginning is 0. So right on this one, try to do this one from the table. Got the answer or not? If you got the answer, means that you understand correctly all these 4 papers. So you have to do it on the paper, how to rotate to X. You can do the A and then do it on the row. Try to rotate it. This is the back side. Right. Okay, 2 more minutes, and then if you cannot find the result, then I'll tell you what happened. 2 more minutes. So anybody got it done correctly? Do you understand? A bit confusing, but for those who understand, try to bear with me. Right. Now let's look what happened. The rotate through X is the one that you need to go through the X flag first. The X flag is the one that from the status register. And normally will be given whether the condition value by default is whether 0 or 1. For this case, both X flags is given as 0. So now what happened? For the question is A1. A1 is like this. A1. And binary numbers is 1 0 1 0 0 0 0 1. So far, okay? So you have to rotate it twice through X. X is given as condition value is 0. This is initial value, they call it. Okay, now what you need to do, look at the table. Table say for the rotate right is like this. Rotate right is like this. The LSB will be copied over to C. The same value will go to X first and push X. The X value will be put inside the register. So the value will push from there and there. You have push people. You have push like that. Push through X. So right now the first shift, the first rotate will be like this. So this one will be copied over to C, correct? So C is equivalent to 1. And this one will be copied, not copied, rotate, rotate go to X. So now your X is equivalent to 1 or 0? 1. It's taking this one. And this value is shift to the right inside here. Remember that it's going in here, right? So now 1, this is 0, 1, 0, 1, 0, 0, 0, 0. Correct? So this is the first rotation. X is already 1, X is already 1. So you have to rotate another time. So again, this one will be copied over to C. C is equivalent to 0. Rotate this one to X. Must go to X. Now your X will be going to be 0. The value from X here will be shift over here, right? Shift, So this is going to be 1, 0, 1, 0, 1, 0, 0, 0. So that is your final answer. A 8. Correct? default your x is 0. If I give you x is equivalent to 1 line, by default if x is equivalent to 1, the value will be different. Faham?
What if the hash was the hash 1? I just put the initial value of it.
Sorry?
What if the hash was
Hash. The value here. Oh, 1. If you put hash 1, it means that it's going to be rotate once only.
So when we put the initial value of it.
Sorry, this is the one, right?
Yeah.
So
Only the initial value of it.
oh no, this is given normally. If this rotate to x, x will be given what's the value. So the question is,
If it's hash 1, I don't think that I can do that.
if this one is equivalent to hash 1, hash 1 means you are going to rotate it once, right? You still have to rotate it once, right?
So the answer will be this one, right?
Yeah, the answer will be this one.
Would be 5 0.
Correct? This is equivalent to a
No, 5 0.
50. Oh, this is sorry. This is not 1. This is correct. This is 5. This is 0. If you rotate it once, it will be like this. The answer. Hash is a number. How many times you rotate? Okay, agree or do not agree? Boleh understand? So it's rotate through x, melalui x. It's go through x. That is the mean of that command. Any question? So rotate left also the same. You got the same answer, huh? You want to do it? This one? Okay, I finish it. Oh, is it okay? Faham? Finish it. So the next one is rotate left through x. The question is the same. A1. The command is rotate left through x is like this. Rotate x through x, rotate left. This is the one. Now you are going to look at this number again. 1 0 1 0 0 0 0 1. So you are going to rotate it the first one to x. The command is like this. So you are pushing here like this. This one will be copied over to C. C is equivalent to 1. 1 is equivalent to x. The initial value is 0. So the same value will be pushed inside here. 1 0 0 0 0 1 0. Correct so far? Okay, now you are going to do it another time. Another time. So C is equivalent to 0. The same value will be copied to x. X is equivalent to 0. And push inside here 0 1 1 0 0 0 0 1. The answer is 8 6. Correct? Slides. Ni. Oh yeah, this one correct. This one betul masuk ni. 0 0 0 0 1. Am I correct tak? Sekejap. Okay, let's do it The first one is correct. Okay, the first one is like this, right? X is equal to 0. Okay, now this value will be copied over to C and then to X. Oh, this one kesalahan. 0, right? So means that here will be 0. Here will be 1. Betul eh? So this is 8, betul eh? 8 and this one is 5. Now you corrected me, it should be okay. Faham tak faham? So through X, so you have to do it one by one. It's quite confusing, correct? It's quite confusing, but you need to refer to the table. The only problem is this command is rotate through X. The rest is okay. Okay, any questions? Then you are finished up. When you finish up. Okay, next one. The last four. There me. Okay, the last four only. We are going to learn bit clear, bit change. So these are the four last commands. Bit change, bit clear, bit set, and bit test. This is very simple. Okay, but you have to do it one by one. Let's try the first one. Let's look at the result. Okay, what does it do? What does it do, right? For these types of command, you need to refer to one flag only, which is a Z flag. The zero flag. So this one is going to change. First test and change, and then clear, and then set or test. This is the command for them. So what does it do? So let's try the first one. Bit change. So these four commands, the first thing is it will test the bit and then change. This one test the bit and then clear. This one test a bit and then set. Set means one. Set means one. The last one is bit test only, check whether it's 0 or 1. That's why it has referred to Z flag only. So let's try the first one. Okay, now try to put up on your Easy System AK the condition here. For the address of FF8000 will contains the data AA. Remember that how to do that? Try origin, try to do it on your PC. Every time you do it, you understand. That's why, hopefully in the midterm you do not remember all these commands. So try to put this value first to this address memory inside your Easy System. This is the default condition. Try. Put this value AA to this value to this command memory. You can put over. There are lots of ways. There are 2, 3 ways. And then you do this command bit test.byte number 3 to this address location. Put the value first. How to put the value inside the memory? There are 2 ways. Whether you want origin or you want to move directly to the memory. Remember that there are 2 methods. Right. How to put the value to this location? You need to put the value in the FF8000 location, and then you can do the bit test .byte number 3. Remember that how to put the value to that value to the particular location. How to put AA? You have to put the value to the location. How? That is wrong. Load AA at 8,000 mana? Kita lihat. Okay, now you done that already. So, okay, the comments like this, very simple. A lot of people do that one. Yeah, it's up to you which one that you want to do. Right? So now your this is AK. Okay, this is my program. So I origin dot FF 8000, right? So define constant dot $5 $AA. So this command is putting the value to the particular location memory. So we just run this one. I can see that my memory, whether I put it correctly or not. Memory for FF8000, the value is AA. Okay, agree so far this one? So the command now say what? The command in the example is doing this one, bittest.5. Bittest.5, this one, and then I can put at my program over here, bittest.5, number 3, FF, this is the location, means you are looking at the value over there. So over here, I just run it, and then you can see the result. So what happened now? Bittest do what? Okay, bit test do what? Look at the definition first. What bit test do? Bit test will test a bit at the destination and sets the flag accordingly. No changes to the tested bit. Okay, define the definition. Say what again? Bit test means that you need to test a bit in the destination and sets the flag accordingly. So remember this for Z flag. If the test bit is equivalent to 1, your Z flag will be going to be 0. If your test bit is equivalent to 1, your Z flag is equivalent to 0. If your test bit is equivalent to 0, your Z flag is going to be 1. This is the function of the Z flag. So right now the command for the first one, bit test. This one, bit test.byte #3. It's telling you to test bit number 3. Bit number 3 from this location contents. So now look at the definition back. So at F8000, the contents is AA. Okay, the contents is AA. Okay, so far? Alright, A is equivalent to 1010. Another A is equivalent to 1010. So the question is testing bit number 3. So bit number 3 is this one. This is bit 0. this is bit 1, this is bit 2, and this is bit 3. So it will test this bit. If the testing say the value here is 1, my Z flag is equivalent to 0. You want to try now, instead of 3, you change it to #2, which is testing this bit. Then you look at the Z flag. What happened to the Z flag? Instead of 3, you change it to 2. The Z will be changing to 1. And the definition say no changes on the bit. Remember that. The definition say the definitions in the table say test a bit and set the Z flag accordingly. No changes to the tested bit. So this bit you test, there's no changes, will be like that.